Okay, so now we can develop our three equation from this figure, which is we have three. The first one is sigma f x direction, sigma f y direction, and also sigma moment. Okay, so our axis will be, normally we'll take this is as x, this is as y. Okay, so sigma fx equal to max, sigma fy equal to may, and sigma moment created by the force towards the moment at the other side. Notice that this ma is force. The I alpha is actually already the moment, so you can compare moment to moment and force to force later on. Okay, so you create the first one. You can start by any of it. You can start by sigma fx, sigma fy, and sigma moment. Okay, so if I start normally I will go first for the sigma moment. Okay, if I put sigma moment in this equation, let's say I put sigma moment at point B, I can eliminate the bx and by. Okay, that means that the thing that I didn't have is only the other part, which is the alpha. Okay, so the bx by I can put away. Okay, if I put the sigma fx, I have the bx. If I put sigma fy, I have the by. Okay, so maybe we start by doing the sigma moment. Okay, you choose one of the direction as positive. Let's say as is sigma moment at point B. So I will take point B for example to eliminate the by and bx. So I can hopefully to have an answer there. Okay. So sigma moment at B. So this is bx and by. So what we have is md g times the distance towards the B. So we said that it is clockwise positive. If I have pin here, so I pull this direction, so we go counterclockwise. So negative. Okay. Just put it first. MD G, and the distance is I've write somewhere. So this is 0.2, 0.4, 0.2, and 0.2. So the distance is from A to B. A to B. Okay, and then we have this one also. I put pin here, so I pull this direction, so it turn clockwise, so it will be positive. MRG. The distance is from B to G of road. Okay. And the last one we have at C point. So C pin here, put this direction, so positive P, which is 50 times the distance from B to C. Okay. So this is at the left part, which is free body diagram. We go to that part equal to, okay. So these two, the MD and A go to point B. So these two we can ignore, which will be 0 in our calculation for the moment. So this one will be 0, this one will be 0. So we only have 4 components. 1, 2, 3, and 4. Okay, we still have 4 components here. Okay, so the first one, I will take this one. I GD alpha, and then if I put a pin here and pull this direction, it will turn clockwise. Okay, so it will be plus this one, MD A GD T tangent plus IG road alpha, and this one also pull this direction positive plus MR AGRT. Okay, this one I forgot the distance. Okay, so you M A times the distance, which is from B to GR also need to times the distance from this one GD to B. Okay, so now this is the first equation. In this one, it might seem complicated because I didn't put any of the I just put some of the numbers. So we have M something. So we replace all the component M, I, and so on with the numbers, and then we will simplify again. Then we have the answer. Okay, so we do one by one. So negative MD 59.81. So I've replaced all these things with the numbers. So we have MD, G, and the distance AB, and so on. Okay, I've replaced one each of it, and then the other part, this is for this one, and the other part we have I. In this case, we have I, which is I for this, we have mr squared divided by 2, and I for road, which is mr squared divided by 12. So I replace it here. The m is 5, r is the radius for this one, 0.1 divided by 2. The alpha is the one that we didn't know, so we leave it as alpha. And then this is md, so m is 5. So we have the second part, which is a tangent. Okay, you have two equations, which is a tangent is alpha r and a normal is omega squared r. So we don't use a normal here, so we use a tangent. So we place by a tangent, which is alpha r. So alpha we didn't know. The r is the distance that we have put from center of gravity towards the center of rotation. So this is r, 0.2 times the GB, which is also 0.2. Okay. Second part we have here IG alpha. So I is ms squared divided by 12. So m s squared divided by 12. Alpha we didn't know, put it as alpha. And then m is here a tangent, which is alpha r. So alpha times the r times the distance for moment. So you notice here that you only have one unknown, which is alpha here, alpha, alpha, alpha. This part is all the numbers. So I simplified here. Numbers become this one, and here we have first alpha, second, third, and fourth alpha. And you solve this one, you get you answer the alpha as 46.3 radian over second squared. Okay, this is the first one. Okay, so we have used the first equation, which is sigma moment, and we get the first answer. Okay, so we can go to the two more equation to solve for by and bx. So that's why normally I will first start by using the moment, because normally you can directly have the answer.